So yesterday you learned some words. The first one was adjacent. So adjacent meant they shared two things.
The same wall.
The wall and
Angle measurement.
a vertex. Okay, shared a wall and a vertex. When I say share a wall, I mean it's between them. Okay, so here's the shared wall, that common side right here, and then that shared vertex right there. So what wall is adjacent to Miss Dix and I?
BC.
Cafeteria.
This wall is adjacent to Miss Dix and I. So some people get mixed up with adjacent. That wall, even though it continues, that's not the wall that's between us. Okay, so remember that adjacent, the wall will be in between. And they will share the same vertex. The second word, once we see a slice of pizza, here's a real life example of adjacent. When you pick up two slices of pizza at once, they are adjacent to each other. All right, the second word we learned was complementary. What did complementary mean?
Completes the other.
Add?
90.
Add, yeah. They add up to 90. The sum of 90, either way you want to do it. They add up to 90. Make sure when I ask what complementary is, you don't say 90. Because what is 90 degrees?
Right.
A right angle. But two angles that add up to 90 are complementary. Okay? Complementary. They could be adjacent or they could be non-adjacent. All they have to do is add up to 90. Here's an example of complementary angles. These two angles made by the second hand, on a clock. The other word was supplementary. Supplementary meant they added up to 180. We grab the door for Mike. They add up to 180. All right, and then I think you were shown this example. But let me just remind you, we talked about complementary and supplementary. Complementary looks like a... starts with a C. Looks like a corner. Ooh, that's beautiful. I was distracted by an AirPod. Can you take it out for me? A corner, which is 90 degrees. S stands for supplementary, and it looks like a straight line, which is 180 degrees. So complementary corner, that's 90 degrees. Supplementary straight, that's 180. So that brings us to, you did this question. We're going to do this question together. It's on page 2. So we're going to start with complementary angles. Complementary angles. I'm just going to write comp so that I can list them. Which numbers are complementary? Which numbers? 49 and 41. So we're going to name these two angles. Let's name 41 degrees first. You did the first example already, right? Yeah.
No, we didn't.
The first example?
We didn't.
You did. Connor, read the paper.
No, I mean we did. I thought we were talking about. No, yeah, we did that.
You did example 1. Yes.
Same with this one.
Wonderful. We're on example 2. Man, you made me erase my screen and everything. All right, so complementary. Add up to 90. That would be 41 and 49 degrees. Let's name the 41 degree angle first. Can I name it angle G? No, because there's two angles with that vertex. So what can I name it? Angle? FGK. I'm going to put a little and symbol. It looks like a plus sign. Or that's what it's supposed to look like. And we're going to name the 49 degree angle. Can I name the 49 degree angle K? I can name it angle K. Why can I name this one angle K? Only one with that vertex. So angle K is good. All right. Then we want to name supplementary. What numbers are supplementary?
131, 49.
Correct. 131 and 49. Oh, sorry, and 49. I pointed to the wrong one. Sorry. 131 and 49, they add up to 180. So let's name that 131 degree angle first. What do we think? Angle?
HGK.
Correct. Angle HGK. And angle K again. The last... Sorry, yes, we're on page 2. The last are adjacent angles. So adjacent angles, they share two things, right? A vertex and a side. Which two numbers share a vertex and a side? 131 and 41. Yeah, I'll explain. It asks in part 2 why these are or are not adjacent. So these are the only two that are, and we'll explain in a second. But let's name the 41-degree angle again. Angle FGK. And then the 131-degree angle, HGK. Whoop. HGK. So those two were adjacent because they shared KG, and they both had a vertex of G. This next question is going to ask why or if some are. So KGH is this angle, and LKG is this angle. It's asking, are they adjacent? Remember that adjacent angles share the same vertex and side. Do they share the same vertex? No. So the first part, the answer is no. What's the vertex of KGH? G, and the vertex of LKG? K. So you could say they don't have the same vertex, they don't share a vertex, however you want to say it.
You can put they don't share.
Yeah. They don't share. Make sure you're listing a vertex. They don't share a vertex. The wall is in between them, but they have to share both the vertex and the wall. All right, and then here we go. Number 2. So we're going to do the same thing. See if FGK and FGH are adjacent. So they share the same vertex and they do have a common wall. But adjacent means the wall is between the two angles. Is the wall between the two angles? It is not between the two angles. So I'll show you. 41 degrees is this angle. I just outlined it right here. 131, or it's not even 131. FGH is both of them combined. Therefore, they are not adjacent to each other because the adjacent wall has to be between the two of them. So between means here's an angle, here's an angle. This is the wall in between them. They're two separate angles. So this would be no. You could just say the wall, or I'll say the side, isn't between them. That's it. Number 3, angle 1 is a complement of angle 2. What does complement mean? They add up to 90, right? So angle 2 is 5 degrees. How do I find the measure of angle 1? Subtract from 90. 90 minus 5 is 85 degrees.
Is that a 1?
This? What do you mean?
Oh, it is.
Number 4, angle 3 is a supplement. Supplement means? They add up to 180, like a straight angle does, yeah. So they're going to add up to 180, so same idea. 180 minus 148. Correct. So the measure of angle 2 is 32 degrees. Questions on this example? You should what? It is on the quiz for sure. Oh, tomorrow? That's not on the quiz tomorrow. Yeah. Next week's quiz. I don't know what they're doing in there. Oh, anyways, maybe you cared, maybe you didn't, but here we are. LMN and PQR are complementary angles. So what does that mean that they do? They add up to 90, so they're going to add and equal 90. So that means we're going to take the measure of angle LMN, add it to the measure of angle PQR, and they'll equal 90. So what is the measure of LMN? 4x minus 2. And the measure of angle PQR, 9x plus 1. And they equal 90. So from here we're going to algebra. What is 4x plus 9x? 13x. Minus 2 plus 1. Negative 1. Equals 90. Add 1. 13x equals 91. Divide by 13. Correct. So then what am I going to do to find the measure of the angles? Plug them back in. So 4, what is it, times 7 minus 2. So 4 times 7 is minus 2, 26. So that's one of them. The measure of angle PQR, 9 times 7 plus 1. And then how can I figure out if I was correct? Add up to 90. And do they? That's it. If you're ready, we can flip to the next page. We do learn 2 more words. 2 more. You what? What is it? Oh, wonderful news. Look at you go. Vertical angles and linear pairs are the last 2 words, and then we just identify them after that. So a vertical angle, essentially, you're going to write down this whole thing. I'm sorry. They're opposite of each other. So vertical angles are opposite of each other when 2 lines cross. They're opposite of each other when 2 lines cross. And they share the same vertex. They are opposite of each other when 2 lines cross, and they share the same vertex. Opposite of each other when 2 lines cross, and they share the same vertex. So, if you have 4 highlighters, that would be helpful, but I would have at least 2 out. So, if you look at this picture, you've got one line intersecting another line. Okay, the angles are located opposite of each other, and they share the same vertex. So pick one of the angles in this picture.
2.
Fine, he said 2 first. What is angle 2? Vertical angles are opposite of each other. So which angle is opposite of 2? 4. So guess what? Angle 2 and angle 4 are vertical angles. So I would have highlighted them and then written under, they are vertical angles. They only touch by a vertex, which is where the vert comes from. Vertical angles share a vertex. So vertex, vert. All right, and then that means angle 1 is vertical with angle 3. Angle 1 and angle 3. You actually see vertical angles all throughout life. Yeah, I'm going to show you some. I drew on my wall earlier, and I've stopped since because it does not erase super well. You can probably see the pink, yes? You can see it? Okay, at one point it was red, so pink is progress. But anyways, these are 2 lines, right? They intersect, and they form some angles. They form 1, 2, 3, 4 angles, just like you see in the picture. The angles that are opposite, so these 2, and then these 2, they're called vertical angles. Okay, I even highlighted some next to Connor. The blue tape, if you see, there are 2 lines that intersect. A line, a line. All right, these 2 angles are vertical, and these 2 angles are vertical. And that's all a vertical angle is. Anytime you see 2 lines intersect, the angles across are vertical. Okay? They're not adjacent, they just touch a vertex, and that's it. Here's what you need to know about them. This is the most important part, so this is what you're also going to highlight. Vertical angles are congruent. Vertical angles are congruent. Vertical angles are congruent. Which makes sense if you look at it. If I were to cut out angle 2, I could flip it around and it would be the same measure as angle 4. All right, so you actually already know how to find all of the angles in this picture. Let's say the angle 2 is 40 degrees. Okay, angle 4 will be 40 degrees. And you can, if not now, you will, be able to find, you should be able to though, find the measure of angle 1. Now look, angle 1 and angle 2, they sit on a straight line together, yes? How many degrees is a straight angle? 180. You have 40 of it. How much is the rest? 140, which means angle 3 would be 140. Yes, you all are. Great job. So vertical angles are congruent. You should have that highlighted so that you'll remember those vertical angles being congruent. The last word we learn is a linear pair. Oh, here's it in real life. A railroad crossing sign. The angles that are opposite are congruent. Opposite are still congruent. A linear pair. I'm not going to write what's on the screen. Here's what you are going to write. A linear pair is adjacent and supplementary. A linear pair is adjacent and supplementary. Adjacent and supplementary. Adjacent and supplementary. So adjacent means they
Share the same wall.
share the same wall and vertex, and then supplementary means they add up to 180. This is why if you have 4 colors, it's really ideal, because there are actually 4 sets of linear pairs. All right, so I pointed one out already to you. You don't highlight what I just did. I'm going to show you the angles to highlight. I'm just showing you why it is the way that it is. So everyone sees this is a straight line, yes? How many degrees is a straight angle? 180. These 2 angles, 1 and 2, they share a wall, this wall, right? And they form 180 degrees. That makes them a linear pair. So what you want to highlight is 1 and 2. And then I would just list it under angle 1 and angle 2. And then under it I would list angle 1 and angle 2 are a linear pair. I'm going to show you another set. Again, don't highlight until I tell you. Here's another straight line, yes? So angle 2 is a linear pair with another angle. What else is angle 2 a linear pair with? Angle 3. So angle 2 and angle 3 are also a linear pair. Again, they sit on that straight line together. They are adjacent. They form 180 degrees. I think you're going to start seeing the pattern. What else is angle 3 adjacent with? Angle 4. And then there's one more pair. Angle 4 and angle 1. They are adjacent and supplementary. It's okay. Just focus, and I will ignore it. Again, so let's say that angle 2 is 30 degrees. You could find every single other angle. You could find the angle next door because they're going to be adjacent and supplementary. So what would angle 3 be? 150. Okay, which would mean angle 4 would be 30. And again, these are vertical, right? So they should be congruent. All right, and then next door should also still be 150. They should be adjacent and supplementary. So you might see like this. This is the more complicated way to see. But in reality, you see it mostly like this picture, where you have a straight line and a ray coming out of it. So 5 and 6 would be a linear pair. So I highlighted one over next to Connor again. So this part of my board is a straight line, yes? And the tape is a line coming from that. So it forms 2 linear pairs. Same thing over here. This is a linear pair with this angle. Okay, up here, this angle and this angle, they form 180 degrees. They're also a linear pair. They're all around us. All of all of the center blocks, if you look up above all of the lines, right? The vertical are opposite of each other. The linear pairs will be right next to each other. So they're just everywhere in life. Why do you tell me this, Miss Marshall? You will have a project. This is the only one that is not done in the room because you're going to find pictures in real life of some of these geometry terms, and you have to take a picture with them. I'll explain the project when we get there. Yeah, I'll explain the project when we get closer there, but you'll want to start gearing up for that. All right, so linear pairs and vertical angles. We're going to find them both in this first example. I will tell you that this example is harder than what we will start with. We'll start with problems like this where there's two angles and you just have to tell me what the relationship they have, and then we'll work our way up from there. But we are going to do this because it is a part of, our curriculum. But we're going to first find the linear pairs. Linear pairs. Linear pairs sit on a straight line, yes? So I'm just going to go through each straight line and figure out if we have a linear pair. Okay? So I'm going to start with this straight line because that's what I picked. All right, let's look at the top. A linear pair. When you put on a pair of shoes, how many shoes do you put on? Two. All right, let's look up here. A linear pair are both adjacent and supplementary. A lot of students would think 1 and 3 are a linear pair because they sit on the straight line. However, are they adjacent? No. And remember that 180 degrees is how much of a circle? Half of a circle. So if this were a pizza, is slice 1 and slice 3, is that half the pizza? No. It is not. It's missing that second. So 1 and 3 are not a linear pair. All right? So we looked at the top of this line. We're going to look at the bottom. What about 4 and 5? Are they adjacent? Yes, they share this wall. All right, and then do they make together 180 degrees? Yes. Yes, they do. They make a half of the pizza. So yes, angle 4 and angle 5 are a linear pair. Some of my students, I haven't heard it as much recently, but in previous years they said to look for a T or an upside down T, or even sometimes it'll look like a Y, depending on. But you're looking for a line and then a ray. That's all you're looking for. So that was our first set. I highlighted this line. Now I'm going to keep going through the lines. Let's look at this one. Let's look at the left side. Are there two angles that are adjacent and form 180 degrees? 1 and 4. So 1 and 4 are a linear pair. And on the right side, do I have two angles that are adjacent and form 180 degrees? No. So there are none there. So again, we looked at this line and found a linear pair. We looked at this line and found a linear pair. Is this a line? No. Remember, lines don't end and they don't start, right? This is a ray. So there's not going to be a linear pair. It's just not going to happen. So that's it for linear pairs. There was just 1 and 4, 1 and 4, and 4 and 5. Those were it. It does ask for us to find vertical angles. I think these are even easier to find because what forms a vertical angle? Two something or others. They're opposite of each other when what? Two lines intersect, right? So you want to look for two lines. We already had highlighted them earlier, right? These are two lines that intersect. So which two are opposite and only share a vertex? 1 and 5. 1 and 5. And that's actually going to be it. 4 would be vertical if this were one angle. This 2. So it's still supposed to be a pair, two angles. So if this ray wasn't there and this was one whole angle, then they would be vertical. But they're not. So that's it. You can turn the page. All right, I would put a star next to this question. You will see it again in the very near future. I would also just like to point out that this question is separate from the picture below. My last class, someone thought they were the same, but it's a separate question. This is all we have, these words. So two angles form a linear pair. This is super important to us because it will help us draw a picture. So a linear pair looks like a line and a ray. Two angles that are adjacent. They form 180 degrees. You can draw it like this. What do we know about the measures of a linear pair? They're adjacent and they're supplementary, right? It's not that they're 180. What do? They add up to 180. So keep that in mind. We're going to have one angle plus another angle equals 180. All right, that's what a supplementary means. One of our angles is described to us. It's 5 times, so it's multiplication, right? It's 5 times the measure of the other angle. Do we know the measure of the other angle? No. What do we normally call something in math that we don't know the measure of? X. So keep in mind for the future that X is representing the other angle. I wrote it off here because it's important. We need to know what X stands for. Okay, so one of our angles is 5 times the other angle. We're going to find the measure of each angle. So we know one of them is 5x, right? 5 times x. Because this means 5 times the other angle. What do we call the other angle? Call it x. That's what x represents, right? The other angle. So one of them is 5 times the other, and one of them is the other. So now we know they add up to 180. We're going to add them. 5x plus x equals 180. You don't have to put these like blanks. I was just showing you two things we're going to go there. So 5x plus x makes 6x equals 180. Divide by 6. Correct. So we want to find each angle. One of them was x, so we found one of them. The other was 5 times x. So what's 5 times 30? 150. Yeah. And then what should these two add up to? 180. So a lot of people get this wrong because they say 5x equals 180. But that would be you saying one angle equals 180 degrees. But them added together makes 180. Okay? You will see this again. The only thing I'm going to tell you right now, the only thing that changes is this number. So make sure you keep looking back at this question. Do you have any questions about it? Okay. The last thing on our notes is this diagram. We're going to decide what we can conclude and what we can't conclude from it. The first thing says angle DBE, and blank are adjacent. It actually has two angles that are adjacent to it. So what is one of the angles? Angle BEC, EBC. The vertex got to be in the middle. Or did you say DBC? No, it's EBC. Or CBE, either way. So EBC. What is another angle that is adjacent to this one? Correct, ABD. So we can conclude that from this picture. The second thing we can conclude is that we have a straight angle. Which of these is a straight angle? Angle ABC. All right, then we're going to decide what we cannot conclude. In this picture, what does your brain tell you is happening? You look at this and you think something. What are you thinking? If you had to make guesses. That is what? It's not linear. Well, they are not linear pair. That's good. We can conclude that from this picture. So I will tell you. A lot of people will think that ADB is a right angle. Why is it not a right angle?
Because it's not on the right. It's still left.
No, it's to the right.
It doesn't matter. So a right angle can open left or right. It doesn't matter. It doesn't have the box, so we can't assume that it's a right angle. So we can't assume, you want to put angle ABD, or we can't assume that DBC are 90 degrees. We cannot assume it. It's not drawn for us in the picture. And I'll actually show you what would, and he kind of already said it. What would be there if they were right angles? A box. So you won't ever see two boxes because I'll show you why. How many degrees is a straight angle? 180. If this portion of it were 90, what is 180 minus 90? 90. So the other one is by default a 90-degree angle. So you won't ever see two right angle boxes because it's assumed that 180 minus 90 is 90. Okay? The second thing we can't assume, okay, B is B a point in this picture? Yes. Where multiple lines intersect, they're not going to put a dot, but it is a dot. We can't assume that B is the midpoint. What would be there if B were the midpoint?
A line would be through, right?
The little lines, the little congruent marks that look like this. Doop, doop. Those would be there, but they're not. So those are just some examples. In Chapter 2, we do more of this. What can we conclude from this picture? What can't we conclude? You won't usually have to list them. You'll just have to decide, it'll be multiple choice, and you'll circle all the ones you can conclude or cannot.